Welcome to the course Depreciation, Alternate Investment and Profitability Analysis. In this lecture we will be covering module 2, which is alternative investment, and in this module we will cover annual cost method part 2. In this part 2 we will take some difficult problems and we will solve it using annual cost method. Now, in the first slide I have shown the formula. In the first slide I have shown how to derive the formula for the annual cost method, and based on this formula we will solve our numericals. Now, this is the first numerical, and this objective of this numerical is, given different capital investments, different salvage values, attractive rate of return, unequal estimated lifespan, annual operating cost, compare two different investments based on annual cost method. Now, here again we have machine A and machine B. Now, capital investment is 45,000, this is 30,000. Estimated useful life, that is N, value is 15 and 10. In earlier cases we have taken N to be same. Salvage value this is 5,000 and this is 2,500, this is also different. Operating cost this is 8,000, this is 15,000. Now, we see that though the machine B requires less capital investment, that is 30,000, it needs more operating cost, that is 15,000, and here it takes more capital investment 45,000, but less operating cost, and hence in such type of problems basically we need annual cost method to decide upon whether we should go for machine A or machine B. Now, the investment for machine A the initial investment is equal to rupees 45,000. The salvage value is 5,000. Now, if I take the timeline at t equal to 0, I am investing 45,000, t equal to 0, and at t equal to 15 years I am getting rupees 5,000. So, in this case the depreciable amount is not 45,000 minus 5,000, because they are at different time periods. So, what we have to do, we have to bring this 5,000 to this timeline t equal to 0, and then we deduct from 45,000 to find out the value of the initial investment. basically. Now, if I want to do this, so I have to find out the present worth of this, present worth of rupees 5,000 is equal to 5,000 divided by 1 plus the interest rate is 10%. I am sorry, I have left it, this is 10%, this is 10% is equal to 0.1 due to 10% to the power 15, and this converts into rupees 1196.96. That means, when I take this 5,000 to t equal to 0 to present value, this becomes 1196.96. So, the capital expenditure at the start of first year, this is the start of first year, is equal to 45,000 minus 1196.96, that comes out to be rupees 43,803.04. Now, I have to find out the annual cost of capital recovery, annual cost of capital recovery is equal to capital investment, this is rupees 43,803.04 into 0.1 divided by 1 minus 1.0.1 to the power minus 15. This is my capital recovery factor, and this gives me rupees 5758.95. So, here I can write down my capital recovery factor, that is capital recovery per year, is 5758.95. Similarly, I should calculate for machine B. Now, for machine B, this is rupees 30,000 and salvage value is 2,500, and this 2,500 I am going to get at the end of 10th year. So, in the timeline at t equal to 0, this is t equal to 10, I am getting 2,500 here, and t equal to 0 I am investing 30,000. So, I am sinking this 30,000 here and I am getting 2,500 here. So, this has to be brought to my 0 timeline. That means, I have to find out the present value of 2,500. So, present value of rupees 2,500 is equal to 2,500 divided by 1 plus 0.1 to the power 10, and this comes out to be rupees 963.86. So, when I put it from here to here, this becomes 963.86. So, the capital expenditure at the start of first year is equal to 30,000 minus 963.86. It comes out to be rupees 29036.14. Now, annual cost of capital recovery, annual cost of capital recovery equal to this 29036.14 into this factor I, that is 0.1, 1 minus 1 plus 0.1 minus 10, and this comes out to be rupees 4725.5. So, here this becomes 4725.5. Now, to calculate the total annual cost, I have to add the operating cost So, I have to add this operating cost with this, and I have to add this with this. So, if I add, this is $8,000 plus 5758.95 equal to 13758.95, and if I add this 15,000 plus 4725.5, this is 19,725.5. As the annual cost of machine A is less than machine B, so my selection will be machine A. Now, let us take another example. Now, the objective of the example 2 is that given the capital investment at different timeline, attractive rate of return, unequal estimated lifespan, annual operating cost, compare two different investments based on annual cost method. Now, the example 2 tells two plants A and B exist for building construction. For plan A, and total initial investment of 60 lakhs is required, of which 40 lakhs will be spent on permanent construction. Now, this is a trick. Permanent construction means lifespan n is equal to infinite. Now, how to handle the cases which has got n equal to infinite, and how to calculate the capital recovery factor will pose some problem, and we will tackle this. And the rest 20,000 will be spent immediately on a temporary structure which will require renewal every 15 years. The annual operating cost of plan A will be 50,000 every year. However, for plan B, an initial investment of 40 lakhs is required on a permanent structure, again permanent structure. In addition to it, an additional investment of 30 lakhs on a permanent structure is required after 10 years from now. So, after 10 years again a investment of 30 lakhs will be done on permanent structure is required after 10 years from now. The annual operating cost of plan B is 20,000 per year. If attractive rate of return is 10%, land is free of cost and is not to be included in computation, then using annual cost method find out whether you will prefer plan A or plan B. So, complication in this plan has come due to this permanent structure. In this problem, investment are done in different timeline and these are to be brought into one timeline before the application of annual cost method. While finding annual capital recovery of permanent structure is assumed, in a permanent structure it is assumed that the n will tend to infinite, and if this n tends to infinite, then I 1 plus I to the power n divided by 1 plus I to the power n minus 1, that will tend to I. Thus, the case becomes a case of perpetuity. If we remember, in the perpetuity, to find out the perpetuity, we multiply the investment with I. So, it becomes a perpetuity. So, for plan A if we calculate, the annual capital recovery cost for rupees 40 lakhs and at 10% interest rate will be 40 lakhs into 0.1. Why 0.1? Because this is the value of I, and here we have seen that while to convert this factor which is used for capital recovery, the whole factor moves towards I when n moves towards infinite. So, the annual capital recovery cost for a permanent factor can be calculated by multiplying its cost with the value of I, which comes out to be rupees 4 lakh. Now, another capital recovery, another 20 lakhs is being done. Life of the structure is 20 years. So, annual capital recovery cost for rupees 20 lakh is easy to calculate. This is 20 lakh into 0.1 divided by 1 minus 1 plus 0.1 to the power minus 20 years. This is 15. Here in the question, the renewal will be required every 15 years. So, it is 15. Now, this comes out to be rupees 262,947.55. Now, after 15 years, this structure has to be rebuilt, and when it will be rebuilt, at that time also the annual capital recovery will remain this 262,947.55, provided the cost of the structure does not change. Now, annual operating cost is rupees 50,000. So, to find out the annual capital cost, annual cost, this is total annual cost, we will add all these three, that is rupees 4 lakh plus rupees 262,947.55 plus rupees 50,000. This comes out to be rupees 7,129,47.55. So, annual cost for A is this, total annual cost for project A is equal to rupees 7,129,47.55. Now, let us do it for plan B. If we see the problem plan B is also investing 40 lakhs rupees on a permanent structure at t equal to 0. So, annual recovery cost of rupees 40 lakhs on a permanent structure is equal to 40 lakh into 0.1, which is the value of I. Now, this becomes 4 lakh. Now, the present worth, now if you see the timeline, for B at t equal to 0, we are investing 40 lakhs. After 10 years, we are investing 30 lakhs on a permanent structure. So, first we have to do bring this to this timeline and then multiply with the I. So, the present worth rupees 30 lakh is equal to 30 lakh divided by 1 plus I to the power 10, and this comes out to be rupees 11,566,29.87. So, the present worth is this 11,566,29.87. Now, taking this structure to be permanent, this is a permanent structure. So, the annual capital recovery is equal to rupees 11,566,29.87 into the value of I, which is 1, because this is a permanent structure. So, annual capital recovery will be equal to the value at t equal to 0 into 0.1, that comes out to be rupees 11,566.2.99. Now, we have annual operating cost is equal to rupees 20,000. So, the total annual cost for plan B is equal to rupees 4 lakh plus rupees 11,566.2.99 plus rupees 20,000, and when we add this up, it becomes rupees 53,566.2.99. So, here total annual cost of project B is equal to 53,566.2.99. As the annual cost of project B is less than project A, this project is selected. Let us summarize this. Common problem confronted in engineering economics are those where alternative comparison between two or more mutually exclusive alternative investments compete, involving different series of capital disbursement. That means the disbursement are at different time. In the present lecture, I have taken one of the methods which is called annual cost method to tackle such problems and to select one of the alternatives from mutually exclusive alternatives. In this annual cost part 2, we have taken some difficult problems and we have shown how to tackle this using annual cost method. Thank you.